Hello, math students. This is Saxon Algebra 2, Lesson 26b, Overlapping Triangles. Here we see overlapping triangles. It is easy to pick out the big triangle. It's the first thing you notice. It has sides of length b plus c, e plus f, and d. Only a single angle is marked, angle A. It is not as easy to pick out the other triangle, but it shares angle A with the big triangle. It has sides of length B, E, and unknown. The side that is in the middle of overlapping triangles is always parallel to the corresponding side. Later we'll see them actually marked that way. The best way to solve overlapping triangles is to take the time to separate them. Also remember, overlapping triangles are always similar triangles. Similar triangles have three congruent angles. The overlapping triangles have two congruent angles, which we designate as capital A. They share angle A, and they both have a right angle, which means that their third angles are also congruent. We know that AA goes to AAA. They are similar triangles. Consider these overlapping triangles. Admit it, this diagram looks a bit tricksy. Now consider this diagram. The triangles have been separated. Ask yourself, which one looks like I could solve it in a jiffy? Obviously, the one below. Everything is so clear. I cannot emphasize this enough. Take the time to separate the triangles. The solution process is the same whether you separate them or not, but you are much less likely to make a mistake if you only take the time to separate the triangles. Now let's solve example 5, our one and only example. The problem says find A, B, and C. They are similar triangles by AA goes to AAA. Therefore, we can find C straight away. We set up a proportion. C is to 4 as 6 plus 4 is to 6, which equals 10 is to 6. Using algebra, C equals 40 divided by 6, or 20 divided by 3. So we're 1/3 of the way finished. C equals 20 divided by 3. We've got C, now let's get A. Both of the triangles are right triangles, therefore we can apply the Pythagorean theorem. We only need the smaller triangle to find A. Using Pythagoras, A squared equals 6 squared plus 4 squared, which equals 36 plus 16, which equals 52. So A equals the square root of 52, and the square root of 52 simplifies to 2 square roots of 13. We're 2/3 of the way there. Lastly, let's stick with similar triangles to solve for B. We can set up this proportion, A plus B divided by A, look at your corresponding sides, equals 10 divided by 6. Multiply both sides by A plus B equals 10A divided by 6, or 5A divided by 3. Subtract A from both sides. B, which we're looking for, equals 5A divided by 3 minus A, or 5A divided by 3 minus 3A divided by 3, which equals 2A divided by 3. So b equals 2a divided by 3, and now we can substitute for a. b equals 2 times 2 square roots of 13 divided by 3, which equals 4 square roots of 13 divided by 3. We are finished. Some questions about example 5 that might come to mind about solving for b. Number 1, why did I wait until the end to substitute 2 square roots of 13 for a? Simply because I find it easier to work with a than to work with 2 square roots of 13. But it is perfectly okay to substitute for a right away. Secondly, why did I choose to use similar triangles to solve for b rather than Pythagoras? I could have used Pythagoras. You could use Pythagoras, but with my experience, I could foresee this happening. A plus b quantity squared equals 10 squared plus c squared. So far, so good. A squared plus 2ab plus b squared equals 100 plus c squared. And then we substitute for a. 2 square roots of 13 squared plus 2 times 2 square roots of 13 times b plus b squared equals 100 plus 400 divided by 9. Really messy. That's why I chose to use similar triangles to solve for b. Recap. Dealing with overlapping triangles. Take the time to separate the triangles. This means drawing your own diagram of the 2 or more overlapping triangles. If you have right triangles, you can use the Pythagorean theorem, but this is not recommended if your unknown is part of a sum. Since overlapping triangles are similar, you can set up proportions or use the scale factor. And then it's all just algebra. I hope this video helped you to master Lesson 26B, Overlapping Triangles. See you next time.